All right, so this video is going to go over the back side of the notes that we worked on today during class. So it's going to give you some steps to break down, and we're going to go through the first example. We already did this problem in class, but we're going to use the steps from your worksheet. So I'm just going to tell you when I'm on step 1 and step 2. I don't want to confuse you with what number I'm actually on. So I'll just tell you what step we're at. So the first one says to find the reasonable restriction on the domain. So this is talking about the radical. So what we mean by this is if we're taking the square root of x plus 7, I can only take the square root of a positive number or 0. So what we're saying here is that x plus 7 has to be bigger than or equal to 0. So if x plus 7 is bigger than or equal to 0, then x is going to have to be bigger than or equal to negative 7. So that's the first part of our restricted domain. So that's step 1. And then the second part says find any other reasonable restrictions from the non-radical side of the equation. So I'm going to do this in blue so that you can see where I'm at. So this was step 1. I guess I will use numbers. This is step 2. So what we're saying here is that if this side of the equation has to be positive, because we're taking the square root of something, or 0, this side also has to be positive or 0. So x plus 1 is also going to be greater than or equal to 0. Whoops. So if I subtract 1 from each side, x has to be greater than or equal to negative 1. So whatever answers we come up with, they not only need to be greater than or equal to negative 7, but they also need to be greater than or equal to negative 1. Since everything that's greater than or equal to negative 1 is also greater than or equal to negative 7, we're a little bit more interested in this one. So I'll switch back to pink so you know where I'm at. So for number 3, we want to undo the radical. So we're going to go back to the original equation. I'll actually just rewrite it here. So x plus 7 square root is equal to x plus 1. So in order to undo this, I'm going to square it. So when I square both sides, I'm going to get x plus 7 is equal to, and this you can use a box for if you're not sure how to square that. You should get x squared plus 2x plus 1. So I'm just making that a little bit shorter. So I'm going to go ahead and subtract x and subtract 7 from each side. And I'm going to get to step 4, which says we want to simplify the equation and rearrange such that equal to 0. So this side is now equal to 0 because those guys canceled out. Over here we've got x squared plus x minus 6. So from there, step 5 says that we want to solve the resulting equation. So in order to solve this, we're pretty lucky because this time you can actually go ahead and factor it. You should get x plus 3 times x minus 2. And when I solve, I'll figure out that x equals negative 3 or x equals a positive 2. Those are my answers. So step 6 tells us that we need to check to see if any of the solutions need to be eliminated based on the restrictions from step 1 and 2. We're going to check by just plugging those in. So remember before we said we're a little bit more interested in this domain restriction because if it's bigger than or equal to negative 1, it's already bigger than or equal to negative 7. So what I see here is that negative 3 is not bigger than or equal to negative 1, so this is an extraneous solution. Okay, so we're going to go ahead and move on to number 2, and obviously x equals 2 works because 2 is greater than or equal to negative 1, so that one's good. So we'll move on to 2, which is going to be a little bit trickier. So you can do this on your graph as well. If you look on your graph at the intersection point, there's only going to be 1, and it's going to be kind of a nasty number. So we'll see how we came up with that nasty number in just a second. So for step 1, we want to figure out a reasonable domain. So we know that 2x plus 15 needs to be greater than or equal to 0 because in order to take the square root of it, it has to be 0 or a positive number. So when I solve for x here, I know that x needs to be greater than or equal to negative 7.5. And if I move on to step 2, I also know if this part's going to be positive or 0, that this part also has to be positive or 0. So x plus 7 also needs to be greater than or equal to 0. So if I subtract 7 on each side, x needs to be greater than or equal to negative 7. So again, anything that's greater than or equal to negative 7 is also greater than or equal to negative 7.5. So I'm going to use this one as the more important one. So we'll move on to number 3. We're going to undo the radical. I'll write it in black so you see the original one first. So 2x plus 15 square root is equal to x plus 7. So I'm going to square both sides. Remember, whatever you do on one side, you need to do on the other side. So this is 2x plus 15 is equal to x squared plus 14x plus 49. So if you're not sure how I got that, you can use a box and multiply through. So for step 4, we want to make one side equal 0 because this is just a quadratic equation. So we want to make one side equal 0 so we can solve it. I'm going to subtract 2x and subtract 15 from both sides. So I get 0 is equal to x squared plus 12x plus 34. So I tried to factor that earlier and I realized it is not factorable. So I'm going to have to use the quadratic formula. So we're on step 5 where I'm actually solving the resulting equation. So I know that the quadratic equation says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug in what I know, I'll get negative 12 plus or minus the square root of 144 minus 4 times 34, all divided by 2. I'm going to keep simplifying that. So x is equal to negative 12 plus or minus the square root of 8 divided by 2. If I keep simplifying, I get negative 12. Get negative 6 plus or minus the square root of 2. So if you put that into your calculator, you should get numbers that are approximately negative 4.59 and negative 7.41. So if these are our x values, and we look back at our restricted domain, so we're on step 6 now. Oops. I want to know, are both of these numbers bigger than or equal to negative 7? Well, negative 4.59 is greater than or equal to negative 7, so that one's okay. X equals negative 7.41, we'll just check as negative 7.41 greater than or equal to negative 7. No, it's not. So x equals negative 7.41 is extraneous. And you'll see on the graph, if you were to graph both of them, that you will only have one intersection point. So moving on to the last part, 3, this one's going to be a little bit uglier as well. This one actually is factorable, so that should be a little bit easier for you, but we'll go through each step again. So step 1, we're looking at what's actually inside the square root sign here. That's got to be bigger than or equal to 0. So if 24 minus 25x is greater than or equal to 0, then x has to be less than or equal to, because you'll divide by a negative sign, so you have to switch the inequality. So 24 25ths. And for part 2, this part's also going to need to be greater than or equal to 0, because when you take the square root over here, that will be 0 or positive. So this side also has to be 0 or positive. So 5x minus 6 needs to be bigger than or equal to 0. When you solve that, you should get that x needs to be greater than or equal to 6/5. So step 3 asks us to undo the radical, which means we need to square both sides. So square here, square here. This side gives me 24 minus 25x. This side gives me 25x squared minus 60x minus 36. Plus 36. So then I want for step 4 to make this equal to 0. So from there, I'm going to subtract 24 from each side, and I'm going to add 25x to each side. So I'm gonna just pinch that because we'll need a little bit more space. From here, we've got 0 is equal to 25x squared. And then we have minus 35x plus 12. So from there, we're going to need to use factoring. So you can use the quadratic formula, but factoring might be a little bit easier in this case. So 25, 35, and 12 don't have any common factors. So I'm going to use the diamond and the box. I'm going to put my 25x squared up here, my 12 down here. So I need two numbers that multiply to 300x squared and add to negative 35x. So you can pause this for a second as you try and find two factors. I'm going to use negative 15x and negative 20x. So when I plug those in, I can go ahead and factor. So this is going to be 5x minus 4 and 5x minus 3. So 0 will equal 5x minus 4 times 5x minus 3. So for step 5, I guess I sort of already started step 5, kind of started up here. We need to finish solving. So x here would either equal 4/5 or x would equal 3/5. So for step 6, it's asking us to check this with the domain. And the domain earlier said that x needs to be greater than 6/5, and it also needs to be less than 24/5. So both of these numbers, 4/5 and 3/5, are both less than 24/5. However, neither of them are bigger than 6/5. So since 4/5 is not greater than or equal to 6/5, and 3/5 is also not greater than or equal to 6/5, you have no solution. And if you look at your graph, you have something happening this way and something else happening this way. So they're not going to intersect. So this is a no solution, and that's what that will look like. So just make sure you have these notes with you tomorrow so that you get credit for watching the video, and have a super night.